Hi, everyone. Glad to have you here and to chat about a topic that I'm so passionate about. I do realize I'm standing between you and lunch, and I presume you've heard enough AI, agentic systems and presentations so far, and you're tired. I'm tired even more. But let's try to make this a little bit more fun and jump into the topic. My name is Tzolov. I'm co-lead for a project called Spring AI. As of recently, we started this MCP Java SDK, which I'm going to talk about and explain what it is. So together with Darius, we're leading this effort as well. And today we're going to talk about how you can put those two things together in order to build agentic and AI applications and what actually agentic application means, at least according to some of the definitions. It is a controversial topic, so we're going to introduce it very early in the presentation to give you some context about what we're going to talk, and later on we'll try to make sense of it. We'll talk about LLM as a system, a little bit recap of what I hope you already know. Emphasize the tools, tool calling, which is a very important concept for the agent in order to interact with its environment, and then bring the model context protocol, this new kit in the block, and make sense of it, how it relates with all these other bits, and talk about agentic system in general. I don't believe into true agent or there is single agentic approach. It's usually a spectrum of solutions, and agentic system is a very nice term to explain this bit. So back to the meat. In order to make use, can you hear me? I can, yes, there is some sort of feedback. So, in order to use generative AI for your application, make use of it and make practical stuff, generative AI models are stateless, frozen in the past, been trained in the past, so they don't know anything about your particular data, and you have to find a way to make them aware of those data in order to ask questions about this. You have to make the generative AI a way to make the generative AI aware of your API tools. And generative AI models are stateless, so you have to find a way to manage state. So in general, those are typical integration problems, and historically Java and Spring are very good in solving these problems. Indeed, Spring AI is this ingredient in the Spring ecosystem that provides all these important building blocks, portable building blocks, various models for different type of deep learning models, like embedding models, image models, audio models. Special emphasis is put on the LLM models, mostly used, and that's what we're going to discuss today. Mostly this is the chat models. We have high abstraction like chat client, advisors, memory support, chat memory support, structured output prompt, tool calling, multimodality, all those goodies that we're going to discuss today. On the semantic search side, Spring AI provides building blocks for abstract you and provide portable abstraction to access various vector stores, simplify TTL to load those vector stores, modular racks, and there is a talk later today that will give you much more details how this works. And model context protocol, pretty good integration, observability all over the place, which is a very important feature for most of the AI solutions nowadays. So, without further ado, what is an agent? As I said, I don't believe that there is a single definition or single true agent approach. It is most of the time an agentic system, and practically, it is a spectrum of solutions that depends on how prescriptive or autonomous the solution is. We're going to discuss this a little bit later, but I believe this definition kind of wraps up all those agentic system purpose and the logic behind. So it is a system that leverages generative AI models to interact with the environment and solves user-defined problems. Generic definition that can wrap all of the different approaches to build agents. Under the hood, agents are composed by definition by two parts. It's the planning part, or the brain of the agent, which in most cases uses LLM, but as of yesterday I learned that you have a special non-LLM solutions that are very good in doing the deterministic planning as well. I'm going to dive into this some other time, but today I'm going to talk mostly about the LLM as the brain of our agents. The responsibility of the brain and the LLM is to find a path to solve the problem. So how to break the big problem in small tasks and actions in order to solve it. Some of those actions may require interaction with the environment of the agents. That means that the agent can ask for email, check the databases or third-party APIs, act and change the environment itself. Normally,
This interaction with the environment are fulfilled with something called tools. This represents metaphorically the body of the agent. And if we put together the brain and the body, so the brain that is capable of reasoning, the body that does tools, this is still not the complete picture. If you remember, the models are stateless. So you need capabilities, and the agent would need capability to retain state about different iterations. And when we talk about iterations, another very important concept of the agentic system is the agentic loop. Practically, unlike the simple LLM solution, generative AI solution, that you have a single shot, you ask a question, you have some response, you deal with it. Within the agentic system, you would have always the concept of agentic loop, where the output in one or other way is evaluated either by the same agent or different agent in order to determine whether the result is good enough, the solution is good enough. If not, it is augmented and tried again up to a certain amount of times, or the result is accepted. So with these general definitions of what we understand as an agentic system, and kind of wraps the boundary of agentic system, let's dive a little bit of the brain of the agent, which is the reasoning part of the LLM. If we look into the LLM as a system, as a simple system, it is a stateless system that takes in and takes out. We should be aware that the amount of text that gets into single input and output, usually measured in tokens, is limited. It has hard limitations, or furthermore, you have to pay for this in many cases. So there's different constraints. You have to be vigilant about this limitation. Another important aspect of the generative AI, which makes it very successful, is that you use human language as an interface with those models. So this is one of the main success stories about the generative AI. On the other hand, in many programmatic use cases, you would want to have structured output, and there is different way to achieve this. Again, another very powerful feature of generative AI is that they're very sensitive to their input. Very little change in the prompt of the generative AI can produce significantly different outputs. So they're very creative. On the positive side, on the negative side, some people can consider this as a hallucination, which is the next thing, so creative hallucinations. And again, they're stateless, and they've been trained up to some point in the time. So we have to be aware of this this issue when you try to bring data, APIs, and memory within our application solution. So when we talk about the input and the prompt of the agent, the quality of the response of the AI model is only as good as its inputs is. And commonly, the prompt or the model context is the things that drives, and the quality of this input determines what is the quality of the output. Normally, you would see that the input of the generative AI would have some structure that looks something like this. It's not prescriptive, it's not definitive, but most of the time you would see the system instructions. Those are the typical instructions that remains the same across the multiple, ground the behavior of the agent or the LLM across multiple interactions with the LLM. Then you have the user part. This is the typical user questions that are passed along with each request the user perform and interact with the LLM. Normally, if the question relates some typical data that is not known to the LLM itself or the brain, you would have to pass additional data or context so that you can ask questions about this data that you want the model to answer or to provide information about. As I mentioned, the models are stateless. So into the context, you have to provision a place where you retain some state of your previous conversation to make the model aware of what you have been discussing so far. And the tool metadata, this is another feature that you have also to provision, but it consumes prompt stuff. I'm going to discuss this later on. Practically, you have to be vigilant that this is limited in size. And there is a trade-off how much of those categories can pick of the whole space available. Memory. I'm just going to mention that when you build this LLM application that requires a conversation memory, this is almost any meaningful agentic system you are going to build, you have to find a way to retain and repeat the memory over time. Spring AI comes with this concept, which is general concept of advisors. It is interceptors. Technically, it is a round advisor that allows you to intercept the input and output of any interaction with the model and build different business behavior. Chat memory is a very typical implementation of this. So there is different version implementation of chat memory advisor in Spring AI that you can plug. So practically those advisors intercept the input and output, and then smartly would know what subset of this data depends on their configuration and implementation to plug into your prompt in order to keep the status and the memory of the conversation. Another thing is adding additional specific information. As I mentioned earlier, the model doesn't know anything about your particular data. It's not been trained, or you deliberately may not want the model to have information about this data by default. So you have to pass this additional context that you would want to ask questions about along with your prompt. This is called the prompt stuffing techniques. We don't have much time to go into detail things. It's a very simple approach. Along your question, you pass the additional data that you want to ask questions about, with some additional instruction how to use this bit, and it was perfectly fine. Simply, it is limited in size, and it's expensive. So if the context that you want to pass simply cannot be fit into the context model, into single request, there is a more dynamic approaches where you can, it's called like prompt stuffing, dynamic prompt stuffing or rack, where you offline are going to chunk, split, for example, entire library in small pieces, put it in something known as a semantic database or vector stores in the combination of embedding models. And the magic behind here, again, there is a dedicated session later today that goes in details about the advanced track options. I advise you to attend this session. So here I'm just mentioning the concept. So with this semantic database and information in place, you can perform dynamic stuffing. Practically, when the user request comes, only subset of the data that is relevant to this particular request is going to be extracted and stuffed into the prompt and asked the question. So then the model would be able to answer with information that is relevant to this particular question. As I mentioned, this whole approach, prescriptive approach to prepare your prompt and stuff it with the right information can be arbitrarily complicated. There is also this well-known paper about the naive versus modular RAG. Spring AI comes with very advanced API support for modular RAG, and I would advise you to attend this session in, I think it's 3 o'clock today, by Thomas Vitali. So let's run with very quick examples just to give you some insight how all those features with prompt management looks into Spring AI. So far, I believe you're familiar that in order to use Spring AI, you have to start with some boot starters. In this case, I'm using Anthropic. I even went smart this morning. I realized that, Claude announced that they just have a new version. I think it was late yesterday or this morning. So we're going to use this new version of the model. That's how you can configure the model you want to use. Of course, you can pick something else of the model for the 10, 15 models that Spring AI supports out of the box. And let's experiment with the first thing. So tell me a joke is pretty straightforward approach. I think this example, this snippet, would illustrate a couple of the concepts that we discussed so far. We're going to, this is how actually you can provide system information. This is the information that is provide the general instruction or the control flow for the agent, how to behave across multiple iterations. It remains the same across multiple calls. Normally, you can use the default system. Then you have the user input, which is in this case, get list of talks, group by task, and list only the sessions with more than one speakers. And here, this is a simple illustration of the prompt stuffing. This is not really a RAG. We're just stuffing this additional content with this placeholder, and this content, in our case, is this information about, I extracted the sessions from the Spring I/O in the Markdown format. So with this data in place, let's run this demonstration, and I'll discuss it. So we illustrate with this how to use system prompt, how to use prompt stuffing, and also this example show you how to do structured output. If you do call and content, it will just provide a textual human response, but you can ask this with the help of Spring AI to provide structured response. In this case, this is a track, talks with authors, and we expect the response to be a list of this. Indeed, and we even had the special request that we expect only a session with more than one speaker. We can see that that's what we received. I mentioned the chat memory. I'm not going to run the example, but just going to show you how you can plug advisor for chat memory that would make your interaction with the model stateful. And there is different implementation of chat memory, long-term, short-term. You can use different stores to store your message data. history data. One of the long-term storage is vector store, so then you can retrieve context-based semantically, not really chronologically. Different approaches, but in this case, this is how we add the advisor. This is memory. In this case, I can introduce myself and then ask what was my name, and the model would know it. Without this advisor and memory, it's stateless, nothing would happen. So I think this gives you some glimpse about how Spring AI, chat client help you deal with all these LLM prompt alterations and augmentations. I want to do a quick demo about the multimodality. So far, we've talked about LLMs. LLMs are large language models. They're text in, text out. But most of the generative AI model also allows you to pass in and out and generate out additional modality like video, images, and audio. In this case, I'm going to show you how you can actually pass audio in and audio out, so the model generates out along with the text. And this is a very cool example, very simple to grasp, but let me show you how it looks like the code and run it. Okay. It's called Audio Chat Assistant. And under the hood, it is again this chat client we create with advisor to have a memory. Is it readable? So, and then the magic is we have this very simple audio client, which allows you to generate or record WAV files and practically audio files in binary and play such files. So it's written in plain Java. We have this infinite loop. We ask the system to record some audio, and then we pass this audio to the model with a prompt. Okay, please answer the question in the audio input. And here is, along with the text, we can pass a different media. So this multimodality, how it works, and this is a byte array of our recorded audio content. When the response comes out, in this case, we get the assistant message out, along with the text that was produced by the generative AI, we're also going to play the media response as well. Let's see how this works together. And what is the prompt that we're going to use? Marine Paranoid Android. So, where is the prompt? To give you some insights about how the system should behave. Yeah, your Marine Paranoid Android, the highly intelligent yet perpetually depressed and pessimistic creature on the planet. So everyone knows the Marvin from the Douglas Adams books. Let's run this demo. Hello, Marvin. Please cheer up the Spring I/O audience here in Barcelona. So now we recorded the audio, send it to the model. It's not real-time model. It will take some time to process, and eventually it will produce a response, which we'll try to play. Which doesn't play. What's wrong? Can you fix the issue?
Ultimately futile. But if it makes you feel better, I suppose I could say hello. Hello, Barcelona. Enjoy the fleeting moments of joy while you can.
Thank you, Marvin. This was really cheerful. Can you give some suggestions for the audience? So it's really brings the mood up when it's down in a wrong way or right way, I don't know.
Oh, suggestions for the audience, you say. Well, I suppose I could share a few pearls of wisdom. Not that anyone ever listens to me. First, remember that life is mostly pointless. The universe doesn't care about your dreams or aspirations. So, why bother? Second, take a moment to appreciate the absurdity of existence. Sometimes, it's all you can do. Lastly, if you find yourself facing a problem, just remember, I've got a brain the size of a planet, and they ask me to come up with suggestions. It's enough to make you weep, if I had any tears left to shed.
Okay, I think you got the idea. So it is multimodality in best, you can see. So far, we were able to grasp the idea behind the brain, what are the internal bits, how it behaves as a system, how Spring AI and Chat Client help you to integrate, configure, and use the brain of agents. Then the body part, this is how the agent interacts with the environment, usually is equipped with tools. That's how actually this happens, and this is consuming some part. In order to use tools, you have to provide some additional tool metadata in your request. The whole mechanics looks like this. If you ask questions like, what should I wear in Amsterdam today? The model by default would say, okay, I don't have real-time information, I would not be able to answer. But because now we provided this additional metadata, which says provide the name of the tool that you as a user on the user or the application side have, the description. Description is a very important aspect. Practically, this is like a mini prompt or information that hints the model when and if it should use this tool for particular cases. And then the signature usually expresses the JSON schema about this tool. You can have arbitrarily long list. Actually, it's physically limited, but there are a long list of tools that you provide to the generative AI. In this case, the generative AI would realize that in order to answer the general question, it needs to obtain some additional information, and instead of providing the final response, it would provide special message back, which is called tool request, with additional information, call this tool that you claim to have with this argument. So you as an application developer somehow would have to implement this invocation, obtain this information calling third-party API or database, get the data in, but this itself is not enough because the model is stateless. You really have to put all the previous conversation to make the model aware of what all this information, new information is related to, and only then the model would be able to answer. So if you do all this iteration by hand, and keep in mind that you may have multiple tool calls, iteration stuff. You have to do it in this way and keep the state and all these bits stayed in right way. But do not despair. Spring AI comes with out-of-the-box support for tool calling, which allows practically Spring AI would automatically detect and dispatch all these tool request messages, distinct them from the final message, and handle them inappropriately with the registered tools, provide the response, provide the state result in order to find the response, the final result. So for the end user, when using the Spring AI, it would feel like you have a single request, single response. Although underneath, most likely you would have multiple iterations in order to fulfill this request. And because it is much easier to show than explain, here is another very short example, exactly about the same question. I think we safely can close Marvin now. He won't be disappointed. So here's our application. To execution. Again, it is the chat client. And only additional information we're going to provide is this a bit better that practically we're going to tell the chat client that it can use these tools. And these tools are this class defined here. There is different way you can define tools within that for the purpose of the chat client and AI in the Spring AI, but the most popular one is annotations. In this case, we are turning this method into a tool method. Here is the magic description. This is the prompt that would hint the model when this method might be useful to use. Then you can have optionally description for the parameter to help the model realize what type of data you expect when this method gets called. And in this case, this method actually really implements a third-party open service that provides weather forecast by latitude and longitude. So let's run this. And there are a couple of things that are important to realize. So we're asking, what should I wear today in Amsterdam and Barcelona? Okay. So we're not asking directly about, here is the response. We're not asking directly the model, what is the weather? So it was the model that realized what tools, in what order, and if to call those tools in order to fulfill the general question. So it's very important thing. So we just provide the information to the model, but the whole control is given to the model to decide. And this already autonomy, some sort of autonomy that you
someone can classify as agentic behavior. The good news is I live in Amsterdam, and I'm really glad that I'm in Barcelona today. So we had 2 requests to the method to get the information from Barcelona, and then this was enough for the model to have nice suggestions for us. So there is some variations of the tool calling. You can specify, you can completely disable this automatic behavior and allows with a lot of utility the user to manage and do this on the client side. There is pros and cons why you might do this. There is another techniques using tool context. You can pass practically additional information that are not shared with the model to your tool calls, usually sensitive information. You can find about all this in the documentation or talk with me later on. Observability. I'm plugging him there because you have observability, very, very strong observability support, which we do not talk very often about. And recent research shows that actually it's one of the most requested features of AI system, which is, I get the intuitions. It's very deterministic and complex system, so it's expected that you would want to have information about what's going on in the system. If we have time left, most likely not, toward the end the presentation, I'm going to run updated version of flight booking demo with MCP support, and I'll show the richness of the tools, the metrics, traces, logging that you can get from our system with proper Grafana dashboarding. So let me recap. We talked a little bit about the brain, what LLM stands for, how we can use it, text in, text out. Then we found out how easy it is to add additional tools to make those LLMs interact with the environment. Very important feature. I would argue that any meaningful AI application would require to have some interaction with the environment in order to fulfill meaningful user tasks. We came very early in the definition of the agent, which has the brain that knows how to plan the task and break the task, the solution in small tasks in order to solve the user request task. And then we have the equipment, which is equipped with tools, has a body to interact with the environment. So it is very easy to build those tools, you notice. So we have all this nice abstraction, but it's a big world, and Java and Spring are not just small island into it. Wouldn't it be nice to be able to reuse tools that someone built already, other language, Python, JavaScript, .NET, and vice versa? You already have put some effort, built for some very sophisticated tool for your applications, for your backend system. Wouldn't it be nice to plug this in some of the existing other systems and actually use it in the context of AI? This is indeed the domain, the primary goal that this new model context protocol aims to solve. So it is an abstraction that allows your AI application or agentic application to access these third-party resources, tools, prompts in a uniform way. Again, model context stands for your prompt, and so this is practically the intuition behind the model context protocol, but by the name means that this is a protocol that tries to unify how you actually modulate, augment your prompt in general. So it is. It's been released, the protocol has been announced, I think, last November, and it became a very popular hit. A lot of, this is very old snapshot. I believe that now there is a MCP hubs, a lot of MCP hubs. It's very interesting. Initially, I saw that various guys tried to create a registry of MCP hubs, with thousands of MCP servers inside those hubs, and then I started to see MCP hub of hub. So I still haven't seen MCP hub of hub of hub, but there is this problem of the discoverability and registry to whole things, but it is very crazy field out there. I believe you can find more than 1,000 servers, few thousand MCP servers out there to augment your behavior. We were lucky to start. We realized that it's a very important feature for the Spring AI, so we had a prototype early on. This was recognized by Anthropic and the MCP Foundation, so the core work of our implementation became the official Java SDK for MCP. It's mostly work that is managed at the moment by me and Darius, but yeah, it's open source project. Feel free to join and improve it. There's a lot of work to be done there. To improve it, there is a lot of challenges. But let's go back to the technical aspect. So technically, architecturally, the MCP is client-server protocol. You have the servers, which is a very important aspect. So far, if you want to build your AI applications, you have to consider all the aspects, including that you have to build the tools, to interact with the environment. So this is part of your design. Now, with MCP, you can kind of separate those concerns. You can have the service provider on one side. Those are the people that know how their service works, what their database serves, their system works, their internal API works. Those people are very best suited to build a thin wrapper around their services and expose it in uniform form like MCP protocol. This is indeed the role of the service provider. And then the people that build the application, I tend to put myself mostly in this role, but yeah, I've been a lot of built servers as well. So, but the point is that the application developer builder now should not be concerned about the capabilities upfront, because it can wire optionally one or more servers or capabilities of those servers that provided with their AI applications at start time. And even better, this can be changed even in real time. So the MCP protocol allows you to change the tools, resources, prompts. I will talk about those capabilities in real time. There's mechanisms to notify the client. So practically, you can start the application with some capabilities, and over time, without restarting it, you can increase the capabilities or decrease them as it goes. It depends on the use case. So, as a cardinality, just to clarify some bits, so very often people get confused when we talk about clients. You have to realize that there is this role of the application client, which actually may host optionally one more MCP clients. And I tend to think about the MCP clients as, yeah, these Java JDBC driver instances to connect to one or more databases. So the more database connection we have, the more instances you would have on the MCP client as well. So that means that you have so each MCP client points to a single MCP server. Of course, the MCP server, especially if it is remotely based, can support more than one MCP client, and the application can have one or more MCP clients, which would enable the capabilities that those servers provide. Another interesting observation is that it is the AI application that holds the interaction with generative AI. Normally, the MCP servers in implementation, they're very focused and they build it around the APIs of those servers. They don't directly talk with the generative AI and not expose for good reasons. There is one feature on the MCP client that allows this to happen. I will explain this in the future in a bit, but let's start with a quick example. Let's now try to wrap our weather forecast application and make it accessible to some third-party AI application that supports MCP clients. So, the very simple one. I would share most of the links of those repositories that I've used. It's the Spring AI examples, this Talent Arena demos, and Spring AI Zero to Hero. This was from the workshop 2 days ago. Let's reuse one of the examples here from the workshop. Okay. Close everything so make it clear. Okay, here is our very same code for the weather tools. It is the same tool calling with the same service behind. And the only thing you should do when you use Spring AI, so I'm not talking, so you have to think that we contribute both, we are working on the MCP Java SDK, which is the low-level SDK, so you can use this as a primitive, which has nothing to do with Spring, so it's a very low-level way to communicate and stuff, but it's much more verbose and involving. And Spring AI provides a nice integration on MCP with various starters and things that use this low-level API to provide all these features much easier to access. And that's what I'm going to use right now. I'm going just to add a dependency, which is the MCP server starter, which automatically is going to use this low-level MCP JDK API and expose these tools as MCP tools in turn. So I have built this as a jar file. Here it is. It's a web server. Actually, it's supposed to be a command line server in this case, but here is the jar. And now I'm going to use a tool called Cloud Desktop. How many of you have used Cursor, Cloud Desktop, Windsurf? Have you used this for? Yeah. Okay, so it's a common client or client application that allows you to interact with one or different models. In this case, yeah, you can. This is the Anthropic version. It's connected to the Sonnet, and I can make it aware of my MCP server. So it works like this. This is how you're configuring this, and this is the free version I'm using. Open with So I already have pre-configured this. Practically, this is the path to the jar that I've just showed you. And in this case, it is inlining the server within the application itself, the client application. There is this concept of transport that I'm going to touch upon in a bit. So with this in place, it's configured. You can even check that apparently now the MCP, this third-party application, definitely not written in Java, knows about our Spring Boot application in this tool. We can even try to use it. I had some trouble this morning because of the release of Sonnet 4. It was a little bit shaky, but what should I wear today in Barcelona? Yeah, finger crossed that the load won't. Okay, so it was able to find our service, code it, and practically provide the same response. So in this case, you can see that some random third-party service actually was able to use a tool that we wrapped and exposed on MCP server in Java. In this case, I've used something called MCP client transport. So this is what we did behind, just add these additional dependencies, well-known annotation tools, and this configuration to plug this into the third-party application. There is a difference. So we use the standard I/O transport. Historically, this was the first transport that MCP used. There is a good reason for this. But if you need something more enterprise-ready, you can run the server into HTTP mode using SEC's back propagation channel and connect to the client. So I usually don't have much time to show, but one very nice example is I'm using C-Line now and then. C-Line comes with support for MCP client. You can see that Marketplace allows you already tons of different MCP server to connect to. You can connect to your private server as well, and I have already, if I start the server, it's here, so, and I can ask exactly the same question, it will provide the same answer, so over the HTTP and SSC. So, another very important concept of the MCP servers is the self-descriptiveness. They come with the concept of capabilities. Both the server and the client can have the provide capabilities, certain capabilities. And the most important one, apparently everyone knows about, is tools, MCP tools. This is maybe most of the time what MCP is being used. But it is very important, and very often people actually ask me, why should we need something else like resources I'm going to explain and prompts in a bit, when you have tools? Shouldn't you be able to implement everything with tools? And it seems like tempting, but many people do not realize who owns the tools and who executes the tools. It's not the application developers that actually runs the stuff. The application only provides the information that a certain tool exists, but the whole control when and if tools are going to be executed is delegated to LLM. So the application developer doesn't have control on this. If the application developer wants to do the prompt stuffing or the RAG and want to prescriptively put some information in the prompt or the model context in order to achieve certain result, it won't be able to do this via tools, but it would have to use more static approach, and this is the concept of MCP resources. You can think of the MCP resources like distributed storage, or a system where for all the tools, all capabilities, tool resources, prompts, the server can provides a way for this client to list those, and also they can dynamically change. Server application can add tools, remove tools, resources, prompts, and send notification to the client to let the client actually update itself. So there is this runtime dynamicity as well. So this resource is very important. You can think of the resource like attachment you put in your prompt. So it could be image, it could be PDF, it could be JSON file. So it depends on the resource implementation. It's identified by URI. Prompt is another feature, which is the prompt templating, which allows you the auto-completion. There is additional APIs for auto-completions. But the point is that you can do most of those things into your Spring AI application themselves. But if you want to centralize it and provide the management of your resources, prompts, into a way that you can reuse it across different applications, even the Spring AI or across the Java ecosystem itself, most likely you're going to implement an MCP server that exposes tools and resources. On the opposite side, the client itself can provide resources. I'm not going to talk much about the roots. This is a way to restrict access to some file system, and at least how the client can inform the server about this. That's not that interesting. The sampling is a very interesting feature that the client provides. If you remember, server doesn't have by default, by design, access to the LLM itself. And you may have a tools, for example, return this, response of this certain database, but I would like you to create me a summary for this response. Normally, this is a typical task if you implement in here that would require to obtain the information, retrieve the information from the database, and then most likely consult some LLM in order to create a summary. But the tools itself and the server doesn't have directly, for the good reason, access to the LLM. You do not want to expose or to hack the LLM inside, because then how many different providers are going to provide to support, how are going to provide support API keys for these providers, and you practically are going to have to implement something like Spring AI into your server application itself. So there are very good reasons why you don't want to do these things, but what you can do is you can actually ask very bad naming sampling. At least I don't understand why they came with it. I would call this LLM invoker. Practically, any of the server capabilities resources here can ask the client via the sampling to talk to the LLM on behalf of the server. So now, if the client asks the tools, please retrieve this information from the database, but put it in certain summarized format, the tools would retrieve the data. Then it's going to send a message to the client, please use the LLM for preferred model to summarize this data, return the data, and this would be the response from the tools. I hope this makes sense, but there is a lot of interactions, but there is a good reason why this exists, and most of those capabilities are optional, so there is a negotiation going between the client and server. Back and forth, this is the first step that happens. But without further ado, so I hope you already have some grasp about whole concept of the MCP. We already noticed how we are building, you can expose our existing tools as MCP servers. Let's do now the opposites. Let's see what it takes to bring additional capabilities to our Spring AI application, but just adding some additional configuration for third-party MCP servers written not in Java. In this case would be, we're going to use capabilities for accessing internet via Brave search with existing MCP server written in JavaScript. And here the diagram doesn't show it, but we also plug in additional file system access that would allow to access certain folders on our file system. So as a code, it looks pretty straightforward. Let's go, okay, it is here. Close this. MCP client. Here is our client, nothing special. Again, we are wiring our builder. I'm even listing what are the tools that this builder is provided with. And then I'm asking something very specific. Does the Spring I/O 2025 conference has sessions about Spring AI and Model Context Protocol? Please provide reference and write summary as a summary MD file into my target directory. Nothing else. I haven't provided any additional tools, but I have added additional configurations. So API client, standard I/O protocol, and here is my configuration. Spring AI allows you optionally to reuse the same configuration that Cloud Desktop provides. And so here is our access to the Brave search and the local file system. So let's run this and hope for the best. So practically, our very minimalistic Spring AI application suddenly acquire capabilities to talk to internet. Here is all the tools that were assigned to our application from all these additional servers: Brave search, local find, read file. We asked and it produced the response. And hopefully it wrote question, does Spring AI response? Yes, it created summary file in the target directory. And here it is. So, Spring AI conference features, okay, I have my session listed in, practically it opt-in stuff, and even this is the workshop we had earlier today. But you get the idea. So with very few little effort, I was able to reuse already assigned capabilities to my server, to my applications, which dramatically extended the things that it can do. It actually was able to reach out to internet, and it was able to write to my file system. Another very important aspect of the Spring AI, the MCP protocol is the security. I mean, the protocol itself specifies the OAuth 2.1 as a specification to access your backend resources. it turns out to be, there was a couple of iterations, it turns out to be a bit challenging. Our Spring security team really jumped in and helped a lot, and shout out for Daniel. I mean, he has a great recent blog published 2 days ago, or 1 day ago, that actually would help you to build the most challenging bits. So there is some interesting aspects that we still have to work out around, but even as of now, you can use this as an example to figure out how you can help to secure the MCP servers using the Spring security underneath. I advise you to go there. And before we finish, let's go back to, I hope that we already have a good understanding of the LLM tools, how the MCP plays a unifying role into this world, providing your AI application with capability to access third-party language platforms capabilities. And when I talk about capabilities, it's not only tools, although that's the majority of the cases people are using MCP server, but resources, prompts, and this sampling feature, which is important. So let's go back to the agentic system now and dive a little bit with all this knowledge we have on the subject as well. I'm going to reuse this blog publication from Anthropic, I think a few months back, where they regard, I really like the definition of agentic systems, where they distinct the range of the spectrum of agentic system based on how prescriptive or autonomous the solution is. If you have a use case where you as a human can prescriptively define the building blocks and the steps in order to solve the problem, this is a very deterministic approach. You are practically wiring your intermediate step. Most of the time, each step would represent something like this, LLM that gets in and out. It can interact with and obtain the additional information with prompt stuffing, retrieval, or use tools, may optionally have a memory. So all these blocks are chained together in order to solve the problem. This is very simplistic and powerful solution because it has a deterministic behavior. But if you cannot upfront decide what are the steps to do, usually you're going to delegate more autonomous responsibilities for LLMs, so to agents itself to decide how to process the path towards, so this more autonomous solution. And depends on this spectrum, there is these 5 patterns mentioned into this block. You can find more information in the block itself. We have our own blog that shows how to implement most of those patterns in Spring AI. It's a very simplistic approach, just to give you the insight about this. But having this in place, I'm just going to walk you through a couple of those. Is it visible? So enough. So, for example, you can think of all these steps here corresponds to one block like this, optional. So for most straightforward approach, as I mentioned, this is a chain workflow. This is the cases where the input and output, so the output of one response can be used as an input for the next one, and you can chain them together. You know upfront how you can break the problem in small steps, and you can execute it. I have a simple example for this. It is into the example repository, agentic pattern, chain workflow. So here is each step is defined as separate prompt to do something. So 4 steps. The general task is, you have this report and follow this 4 steps to provide some response. So practically massaging, cleaning the input, and then providing some structured response. The implementation in this case is really looping through all these inputs. And the important part is that the response, the output for the one iteration, is used as an input for the next iteration. So this is practically chaining them together, very simplistic behavior. If we run it, it would be expected. Oops. Step 1, step 2, step 3, and eventually it would reach the desired output. So this is kind of very straightforward. This is very popular approach. I don't have much time to go into it, but I advise you to get it. It's evaluation or reflection, where you're actually chaining 2 models. It can be very often even the same model, and this is a typical example for agentic loop, where the output of the one model, generated solution, is evaluated by another model, and depends on the assessment. It will be either the final solution or some adjustment on made, and another attempt is requested. There is a nice example here which generates Java code with a description and try you to iterate until you fill some criteria. You can find it yourself. I just want to reach out to maybe the most autonomous approach into this among those patterns. And those patterns, not one or other. It's usually would be combination of many things. It's just a good illustration of the common approaches to address different problems. But the orchestrator worker workflow, practically it uses one upfront. This is the cases where you don't know what are the tasks that are supposed to be performed in order to solve the problem, so you'd have a special AOM that acts as an orchestrator that would going to design the steps in parallel and sequential in order to solve the problem, and then you're going to iterate, maybe do a loop and solve eventually the problem. Again, the simple solution for this in our repository, and I will show you two implementation of this problem because it's very, very important, and we're going to wrap the session. So orchestration workflow, here it is. In this case, we have an orchestration that instructs that you have to generate some task and then with certain format, and then this is the prompt that the tasks perform, and in this case it runs the task, I think, in parallel, and merge the response. So it's not very interesting sequence. I can run it, but I would prefer to move a little bit further, because while working on all these bits and being fascinated with the agentic MCP, this agentic frameworks, patterns, I came across this Python framework, which actually is combining all those things that I'm very interested in. It's called building these 5 patterns from the blog, the MCP, and builds an agentic framework that implements the patterns in a certain way with all these loops. And being me, I went and said, and I've created this Spring AI community project that replicates most of the work. Right now, it implements the most complicated pattern, which is called the orchestrator workflow. It is here. Yeah, you can find it. And for example, you can define the agent in terms of instructions and list of MCP tools this agent supports. Once you have this in place, you can define your problem as a set of agents. In this case, I have search agents with certain instruction. It is going to use the Brave, fetch, and file system, automatically being aware. Then I have a second agent, fetcher agent, and report writer agent. I can combine all those things into an orchestrator, run this orchestrator, and to start this infinite loop until it solves the problem. I just wanted to show you one interesting aspect of this orchestrator prompt. This is practically the operating system for the agent plan. So your task with orchestrating plan for completing objectives. This second one is very interesting. Practically, if you realize, this in fact is the agentic loop implementation for this particular pattern. You analyze the results from the previous steps already executed and decide if the objective is complete. Practically, further down, it actually goes about the format it expects to be provided, and there is this field, is it complete or not? So practically, we have this loop, and this orchestrator would use all these agents to decide, depends on their descriptions and the description of their tools, how to combine them in order to solve the problem, and it would run it infinitely until, so when you run this, you would see something like this. I'm running out of time, I believe. So, and it is still work in progress, but it is a project that I've started and shared on MCP. Yeah, a lot of stuff. It is here, yeah. MCP community site. I encourage everyone to come here. There is another important project which I haven't had time to discuss. In addition to the tools annotation, we're actually experimenting to have MCP resource annotation, MCP prompt annotation, MCP completion annotations, and use it in your application as well. And here is the MCP agent project I've just mentioned. So with this, I believe I managed to cover most of the content. I really wanted to plug in demonstration about this. Recently, we worked with Marcus. Thanks, Marcus. The existing flight book assistant application, which puts together all these bits tool calling, so it talks to the backend system to manage the file system, to manage your booking. And now, yesterday, I said, okay, what would happen if I just plug another MCP server to this existing application? I found random hotel search MCP server, and I was able to okay, please find me a hotel nearby my destination. I come out with nice pictures, prices, and stuff like this, and then I plug the file system. So, okay, please write down the itinerary in my file system. So, with very small things, you can actually extend. I'm going to share the link after the talks one of those days when we clean and make the repository. But it's pretty exciting how things are coming together. And maybe I can think about some agentic loop into how this application to make it more complete and to get nice experience. Thank you very much for the attention. So, that's for me.